Novotny, and I am an evangelist and community manager for community leader, whatever, community person for Nginx. I also do open source strategy with them, and I'm also program chair for O'Reilly Media's open source conference, OSCON. That happens every July. So come join us for OSCON. So Nginx is an open source. Nginx is an open source web server and web application delivery accelerator. In 2002, it began in Moscow. Igor Sistoyev was actually employed by Rambler, which is the search engine of Russia, the large search engine in Russia, and they're functionally the Google equivalent for serverless. And he was having a problem in that he couldn't get enough concurrent sessions on 2002 hardware to make their ops teams happy. So he was trying to solve the C10K problem. He wanted 10,000 concurrent sessions on 2002 commodity hardware. And if any of you seem old enough to have remembered 2002 commodity hardware, we're talking about a gig, 2 gigs of RAM. We're talking about, Pentium something. We're not talking about multiprocessors. We're not talking about shiny, fast, good stuff that we have today. And he spent a bunch of time not trying to fix Apache. He did a lot of modules for Apache, but after that he said, I'm just going to write this from scratch. And his goal was to make my concurrency. So this is a benchmark that shows Nginx requests per second as a function of concurrent connections over in comparison to Apache. So Nginx began and continued to grow as something that was very focused on high performance web acceleration and getting you the best bang for your hardware. The other focus space and big differentiator between Apache and Nginx is that Nginx is an interface system. It's a master and worker model, not a thread and a forked thread for every single request. So what we see in Apache is we see memory consumption increase with the number of concurrent connections because every concurrent connection forks another thread. That's not how Nginx handles this. That all makes sense? How many of you run Nginx right now? Cool, only about half this time. Nice. All right. Yesterday, almost everyone did, which is also very nifty. So I didn't put all of our metric slides in this one, but we are the most used web server in the top 1,000 websites according to website traffic. So, for example, if you guys watch movies on Netflix, it's being delivered through Nginx. So the big 3 questions that you need to figure out when you're just about to start installing Nginx is, what functionality do you really require? So are you just trying to serve static content? Are you trying to do fancy application routing? Are you trying to do more interesting, more complicated load balancing or caching, more granular control of your caches? So there is the core Nginx content. There are standard modules. There are community modules. We now have an Nginx Plus product, which is a commercial offering, and I will talk just momentarily about which later. And then there are all the optional third-party modules. There's a pretty vibrant video that actually shows modules that are compiled in Nginx. So at this point, if you have needs for those modules, you're doing a compiler yourself. Today, I'm going to talk about just a binary install out of our Nginx repositories for simplicity. I'm not going to talk about fancy modules. Second thing that you really need to figure out when you're looking to install Nginx is, what branch do you want? So we have a mainline and stable branch setup, much like other existing products. Our stable simply means we're only backporting bug fixes. Our mainline is where we're doing all of our feature development. It is still considered a fairly stable and robust and well-tested branch. That said, your mileage may vary. It always does. There also are older versions that exist out there. Some of them are packaged with existing operating systems at this point. For example, we just got put into Trusty as the default HTTP server. We also have recently gotten into one of the BSDs. I can't remember if it's open or free. and that's really bad. I would start a war if I said that too loudly. But we are now the default HTTP server in one of the OpenWest free BSDs. In Trusty is the 1.4 branch. There are still PPs that you can use to get the modern branch, or the more recent branches. We just cut the new 1.6 and 1.7 about 3 weeks ago. Oh, for those of you who are Red Hat and CentOS, we have been just also added to the software collections repository, as well as having our own, dump repos for that as well. So most of the time, you can find binary installs from the official Nginx packages, which is how you want to install from the from our Nginx packages. You can find those at nginx.org. You can also build from source, or you can find them, as I mentioned, in the operating system repositories, or for those of you who live out in the cloud, we also have an AWS AMI that we have pre-built for you with our Nginx Plus functionality on it. So the install process, I suspect you guys have seen things like this before. So we actually do key signing, and this is a Debian install. We do key signing, so you first start by pulling in the keys that we have published, and then we have you set up our sources list from where to pull our packages. Pretty straightforward. apt-get update, apt cache policy, and lo and behold, you have your Nginx install. That will actually bring up Nginx, and you can test all of that to make sure that it is working in all of the normal ways. init.d files are there. You can run it and check status. You can find the version. And then, of course, you can check from the web. That's our default page. As a funny aside there, if you don't configure a default server, Nginx will, in the configuration file, choose the default server for you. It's really best practices, and I'll mention this again when we start talking about servers in the configuration file. It's really a good idea to set up a default server. But if by some chance someone goes to a website that is improperly configured, that is running Nginx, they will run into this. And we actually get calls every so often going, what did you do to my computer? Because people end up here. Which is very interesting. You're not technical people. So with our installs, with the installs that come out of our packages, we use the standard configuration setup of user spin Nginx for our executables. We put our configuration files in Nginx, and you can hunt down log files for log Nginx. Pretty straightforward. These all should look like things you've seen before. Yes?
I'm embarrassed to ask, especially in this environment, but is there a Windows version of Nginx?
There is a Windows version of Nginx. We consider it beta, but it is run, and we do compile it, and we do have it available. It is only open source, so you're looking at community support for it. But we do have a Windows version, and I won't tell them that you asked. So as I mentioned, Nginx doesn't use the thread or connection model. And so the processes actually look very different. It's an event queue, and we have one master process that manages, that is actually launched by the unit script or launched by the binary. And that master process controls reading the configuration file and managing its worker processes. The worker processes are where the requests are actually handled. You shouldn't usually see, except in very unusual cases, ever see more than these three processes. So if you're familiar with Apache, you're used to having HTTPD, I have 10,000 connections, I have 10,000 HTTPDs, and my server is misbehaving. In this case, you'll see 10,000 connections talking to two worker processes, and instead using the event system to do that. So you can,
how do you determine then how many connections you have?
So we have a status page that tells you that. So you can actually go to, you can configure that. Oh, I didn't put that in this one. Hey, that's a note to myself. Put status info in here. Okay. So we have a status page that is set up by default that you can take a look at. It gives you information that you can use to find out how many connections you have, that kind of thing. There is an Apache equivalent to just an HTML page that you can look at. I'm not thinking of what it is for. Which my status that shows you that. Okay. So you can see it through that. It's through the status page. The occasions where you might see more than these three processes include if you do an online binary upgrade, you will get yourself set in this space where you have two sets of master processes and worker processes, and so you'll have 6 of them. And that's an edge case we talked about yesterday in other talk. But it's a fun one because you can do online binary upgrades. Did I mention that? So Nginx follows most of the standard commands. So we've got a reload, Nginx -s reload will reload your configuration. We will shut things down with Nginx quit or Nginx -s quit, and you can do the fast shutdown, which is just make it stop now. Those are, again, all pretty straightforward as far as manipulating the binary and what goes on there. So since we were going to reload our configuration with the Nginx -s reload, we should probably talk about the configuration file. So we know where it is. Anybody remember? That's right over there. It's Nginx. All right. And it does actually also follow includes. So if you're more familiar with the different ways you can do includes in Apache configuration files, you can say include a whole directory and anything.conf in there. You can do that in Nginx as well. And it's not a bad model to follow for your if you have multiple servers that you want to, or multiple in Apache lingo, because I'm kind of going to bounce back and forth for those of you who might be more familiar with Apache. Multiple virtual hosts. Same idea, you make a server block and do the same sort of thing with the included configuration file. The main file is called nginx.conf, and it exists in Nginx. The configuration files are filled with directives, blocks, and contexts, and those are subsets of one another. So I'll talk a little bit more about that. A directive is a single configuration statement, so listen on port 80. Sounds pretty straightforward. We run into that. And the parameters and then a semicolon. These are what most of our documentation exists as right now. It's a whole lot of deep engineering speak directives. Here's your thing, or here's your directive, here's your arguments, here's a 2-line summary of how to, or what it does. We are working on improving consistently our documentation to make it a little bit more use case based. So I want to build a proxy server, how do I do that? I want to build a caching server, how do I do that? As opposed to, I want to understand the listen directive. So there are simple directives and then there are also block directives. And the simple directive, like I said, listen, 80, server name, localhost, pretty straightforward. A block directive is a directive that has directives in it. So you start with singular things like the server or listen port 80. That would exist in the HTTP block because that is the largest block that's outside of the configuration file. Everything that you want for the entire master Nginx process. So if you wanted to always listen on 80, great. If you want to always listen on 80, or always listen on 443 and redirect to 80, you would put that in the HTTP block. And that block then contains other directives internal to it that look more like servers or locations, which we'll talk more about. So a location directive, as this example shows, gives you the specifics for a particular URL or URI location. So in this case, it's the root URL, and we want that root file system for that root location directive in the URL to go to user share Nginx HTML. So if you went to myserver.com/ the files it would serve out of this location directive would be out of the file system space, user, share, and Nginx HTML. The next directive here is the index, and that tells you what, if you don't tell it what file you're looking for, what its default file is. It's very much similar to the Apache space. So in this case, if I went to myserver.com/, I would get index.html served out of user, share, and Nginx HTML. Location directive, pretty straightforward. In this case, we can do this, we can use these location blocks, use these directive blocks to have and make decisions in a lot of cases. This is a really straightforward, simple one again, because I'm trying to go through these as simple, basic configs. So this is a case where we have two different locations that are being served out of two different file systems or file directories from the same server block. So this server block may be myserver.com, and if I go to myserver.com/, I will be offering files out of data. Now in this case, I don't have a default index, so I will not find anything. We don't actually drop we don't drop you to a directory unless you request it. So this will tell you that this will error, and you will not find a file unless you know the file name. So if we wanted it to default to an index.html, we would have to put an index directive that gave index.html. In the case that we went to myserver.com/images, we would be serving files out of the file system /data. Again, pretty straightforward. Specifying a server block is the equivalent of, we've been looking at configurations within a server block. Specifying the server block is very similar to a virtual host derivative within Apache. So in this case, we are defining a server block. We can also define what port we want to listen on within a server block. Many of our directives can exist in either the HTTP master block, the server block, or within a location block. Not everything can, but that is all called out in the directive documentation as well. The server block itself exists within an HTTP block. And in this case, we have a server definition listening on port 80 in this case within the server block. Within the server block, we can also name our server. So if you wanted to do name-based service, much like virtual hosts, you can do that within the server block as well. So Nginx then chooses which server block to process based on the name and the listen for it as well. Equivalent to virtual hosting. The location block is where stuff starts to get more interesting to me. Location blocks, as we put in the most basic configuration, we can say images go out of here, root files go out of there. Location blocks can go inside any server block, but they can also have conditionals in them, and they can have a hierarchical order of processing what happens within a location block. So it can contain a root directive, it can contain regular expression matches, it can contain lots more logic as far as what goes on than just this file system, or this URI or URL path to this file system. So the block, any server block can contain multiple location directives, and you will match on the narrowest, most exact match generally. Prefix locations and regex locations also match differently. So a prefix location would be an actual static definition, and a regex location would be a match. You would match a prefix location first. Examples of servers and locations. So kind of continuing to build on this picture. So our server now is listed on port 80, and we have a root directory of the home Nginx.html. But we want to set up a little bit more complexity. So maybe we have an application that's being served out of an application folder and images from somewhere else. In this case, a request transfer the index file in this directory. I mentioned before you can add include files. So this is really straightforward. You include path to file. And we do recommend that, much like the virtual servers of Apache, for each server, you want to create a separate configuration file. And the Nginx conf includes all the files in a confd folder if we said include etc.nginx.d. I mentioned server names. So this is where there will be syntax for actually defining your server name. Now this will do matching. Again, you can also use regular expressions in this, as well as just wildcards. You will match on the most exact match. And you will match the server location for the server block, and then any location blocks under the server block that are offered. In this case, if you are serving multiple URLs out of, or multiple server names out of a single Nginx directory configuration file in Nginx server. Anybody have questions so far? All right. Well, then let's make this more fun. That was about as basic and static as it gets. So in this case, we're going to continue building on that little config file we've been playing with, and we're instead going to do some proxying. So in this case, we're doing a little bit of static file delivery from the location of images, as well as doing some proxying out to other applications. And you'll notice there are two different proxy pass directives in here, and they behave a little bit differently in the sense that the proxy pass to with a location without any actual further URL configuration will pass to localhost unadulterated, for lack of a better word. So if you go to myserver.com/ and I look at the proxy directive there in my server block, it will pass directly to localhost 8080. And this is the most common configuration for an application server if you want to pass something straight through to an application server without adding any additional logic. Now that could be a Python or a PHP or Java application server. So your location, my Java app, myserver.com/ myjava app would be passed directly and unchanged to localhost 8080 my Java app. In the case of the second directive there, location app 1, or location application 1, you are passing it instead to a slightly smarter space. So maybe we're running multiple applications on this backend application server. And so the application 1, so myserver.com/ application 1 will be proxy passed to localhost 8080 / other app. Now in this case, my server.com application 1 / Java fun will actually show as the URL in the bar, and it will be proxy passed to localhost 8080 other app, my Java app. So you are seeing whatever is appended to the URI that's in the location directive there, appended to whatever URI is in the proxy pass directive. So what you will see is what is in the location directive plus everything that the user adds behind it. And what will be delivered is what is in the proxy pass directive with everything that the user puts beyond the original location app URI. If that makes sense. That one's a little bit subtle. Yeah? No, it's not. Okay. Cool. And location images, we're just serving those because they're static. So this is some of the application delivery and a little bit more intelligent layer 7 routing that we are known for, is we can be the front end for your applications, for your website, for any HTTP traffic, be it an API or an application or static content, that can then be smart about sending the requests to the location that best services them. So our role in the infrastructure ecosystem is not to rip and replace. Our goal is not to rip and replace. It's to supplement and help you get the best possible the best possible value for what you are doing. So you don't need to be serving your static images out of your Tomcat server because it's super heavy. Why would you do that? You'll take your Tomcat servers, especially if you also have an image-heavy server or an image-heavy application. So we're trying to give you the tools and the intelligent routing that is available, or that makes you get the best value out of your infrastructure, your tools, your technology. So this starts to look a lot more like this. My last listen directive, is the actual server, saying where we are proxying to. But in this case, it's not really an application server because I just served it out here. But it's good for illustrative services, or for illustration purposes. So logging is really important. Once we've configured ourselves some static content, some proxy passing, but say I'm having problems. I want to be able to troubleshoot this. So we want to, and always of course recommend, that you add logging information to this. Error logs specifically, great fun, can be put in any context. So they can be in the actual file, or sorry, the HTTP context block. They can be in the server or the location or the main context blocks. So they can exist at any level, and again, will match on the most specific. So if you are down in a location block and put an error message or an error log directive, you will match there because it's more specific than your server or your HTTP context block. You also have different levels of logging. This is standard in all sorts of software these days. So you've got your standard info, debug, warning, the classic list. It's long. By default, our packages are not compiled with the debug flag on, and we have sort of a mismatch there because if you have real problems and start asking questions on mailing lists, we will ask you for debug output. So just something to know. We do, I think things default to the, not the info level, but actually I'm not sure where they default to. I'll have to look that one up. For logging best practices, much like Apache, we recommend that you do all of your logging at on a per server level so that you can, unless you need something more granular than that, you can at least separate things out by per server level. You can put them wherever you want. The standards, of course, are logs. And then you can use standard log rotate type tools to rotate them. There was an interesting post a week or two ago about a way to do log rotation within the Nginx configuration file, but it actually is if you don't have high concurrency or super high performant needs, it's a nifty trick to do it. With a bunch of regular expressions, but if you have high performance needs, you want to use an external tool to do your log rotation. So that was a little digression on logging. So the thing that Proxying gave us is the ability to actually proxy up to additional, a group of hosts to an upstream block. So this is functionally load balancing. And you can do this within Nginx cleanly by defining an upstream block that actually gives you the list of servers that are available to provide your service through your server block, which gives you a proxy pass to your upstream block name. That's a mouthful. So in this case, we've defined an upstream block of 2 hosts. They are defined by, in this case, I'm presuming that it's a sort of DNS name. So for the moment, we will call those DNS names. When the configuration file is loaded, that is when those DNS names are resolved, unless you are running a local resolver. So that is something to note. If you want to put in your upstream block, you want to put DNS round robins, they won't re-resolve every time you change unless you're running a resolver locally. There's a change either coming or has recently happened where we will do more resolution, but at the moment, to the best of my knowledge, we are still only resolving those on the configuration read. or maybe it's that Nginx Plus has that one. There is a way to get consistent DNS resolution, but it is not in the default open source product at this point. So in this case, our server block is listening on 8080. We've defined our route, that's great. And we have our error logs, because now it's a good idea to have error logs. But our location block for route is doing a proxy pass to our upstream list. Now, those servers are local in this case, because we are looking at port 8081 and 8082, and those, we will have other services running on those, which I didn't put the configs in for. The nice thing about this is, on top of creating your upstream block, you can actually give server priority. So, in the event that you have one massive server and two little teeny servers, you can tell the massive server that it gets, or you can tell Nginx that the massive server gets more traffic. So, the weight parameter is a ratio. So in this case, in this picture, backend server 1 would get 5 requests for every 3 that backend server 2 got, and every 2 that backend server 3 got. So that was load balancing in a super tiny nutshell. Questions? Question.
Syslog logging?
Syslog logging. At this point, we do not actually, in the open source product, we do not log to syslog directly. The open source product has at the core of it trying to be the most high performance, awesomest, super deluxe, tiny little piece of web application acceleration. And there are cases where logging syslog will block on disk. So we chose not to put it in there. And this is the part where I get to say, we do have that module in Nginx Plus. So you can go to syslog with the commercial product.
This is also how you pass to, like, say, PHP, Ruby.
The proxy pass, yep, that's exactly how you would actually pass things out to a, you could pass it out to a Unicorn server or a Tomcat server or a fast CGI server or a PHP FPM server, yeah. So that is the tooling that you use to go out to an application server as well. Yeah?
Does this do the kind of thing where, once someone's made a request from your server, it will make sure that all subsequent requests from the same host get routed to the same
stickiness?
Yeah.
Session persistence, stickiness persistence, there are ways to configure that. I didn't go over any of that. So at this point, this is just the default round robin. But there are ways to do session persistence in the open source tool, and then there are other additional ways to do it in the commercial one as well. So there are options for both. Yes?
Is there a way for it to detect if one of those backend servers is down?
There is some basic configuration or basic status checking, and it will drop it out and not send requests back to it until it answers again. There is also when servers get added back in, they can be slowly ramped up as well. So instead of it just getting bombed with all the traffic, you can have a slow ramp up as well. There's, again, additional features that are available in the commercial one in the same sort of space. There's much more in-depth health checking in the commercial version. But there is status checking in the open source one. More questions? No? All right. Cool. Reverse proxying and caching. So as I mentioned before, our goal is not to have you rip and replace and completely re-architect everything that you are possibly doing, because that's not the way into an organization. It's let's parachute in and say it'll all be better if you use my thing. No. Let us help you make incremental changes in your infrastructure and your architecture in order to move things faster. And reverse proxying and caching is one of the easiest ones that we do. All of these are pretty straightforward, but in this case, Nginx lives in front of, as I said, other application servers, other web servers, and tries to help mitigate high load, high content, or high concurrency against servers and services that might not be as skilled at that, we'll use that term, that might not be as efficient in handling high concurrency or high loads. So Nginx can be used and configured to just say serve all the static content so that you're only sending information to an application server when it actually is relevant to the application server, when the application server has to do some work for it. You can also use it to cache content. A lot of even the dynamic content that we generate on a given web server is pretty static for some period of time. So either through a session or through my visits from my IP. So even if I'm going to an e-commerce site and it says, hello, Sarah, and that's technically dynamic content, my name doesn't change in the next 6 weeks. It probably won't change in the next 30 years. But we can cache that for you and take some of that load off of the back-end application servers. Static content can also be cached. As I mentioned, Netflix using Nginx to deliver much of their video. Our product, or Nginx, is actually what is behind their CDN that is delivering all of the video content. So it caches, it slices, it dices, it load balances, it does all sorts of cool stuff. So caching, as far as setting up caching, the directives that are interesting in this case are the proxy cache path. So you can tell it where you want to put this actual cache. It has to exist somewhere on disk because we have a disk cache for this. So we don't actually, it's in memory and disk. But this also means that you don't have to do cache warning, which is very interesting. And in this case, so we give a proxy cache path. We tell it what keys we're using, the parameters giving the name and size of the cache, and then how big you're allowing it to get, and at what point you want to remove things from the cache. We do not have very, very granular cache clearing, cache removal at this point. It's something we're working on. So one of the things we frequently get asked is varnish versus Nginx.
So on the so once max size is reached, is it prioritized by something?
Aged out.
Aged out. So if inactive is inadequate, it will just age.
It will age things out.
Okay.
Yep. Proxy temp path drops temp files, pretty straightforward, and both of those exist, or all of those exist in the HTTP context because you're building it for the entire Nginx server binary. Once you actually set up your cache, you are proxy passing to your cache in order to pull information out of the cache. And in this case, we have a server cache called server cache. We have a key that is based on some variable sets, and we are setting our time for how long things are valid, which in this case looks to be 1 minute. And we will give you a 404 if something has gone beyond that. One of the things about proxying that is particularly interesting is if you don't actually change your headers, everything looks like it's coming from the Nginx box. So there are proxy headers that need to be configured to pass your actual application server header or your actual origination host. Doesn't sound right, but apparently it is. In order to make sure that you can do troubleshooting, proper logging, that kind of thing. So you want to make sure that your proxy has those header passing. Well, I did leave in the slides on HTTPS. This really is like super 101 quick. So proxy caching, enough starter there. A little bit of info. Lost you all last week. No? All right, cool. So configuring an HTTP server, one of the other things that in this sort of model of we put Nginx in front of all the other heavy lifting machines, you can offload your SSL or your SSL termination onto Nginx. And in this case, we're just setting up an Nginx HTTPS server. It looks very much like the port 80 ones, only had keys. It's amazing that way.
Is this like you talked to, I guess yesterday you said it was encrypted bulk size, is that?
This, in this case right here, what I am doing is I'm just serving local content from my Nginx server out to the client over HTTPS. if we were using the server block that had a proxy pass that then passed it to the backend block, a recent change is we can now encrypt the traffic that from the proxy pass back to the backend origination server. This is not that picture though. Sorry. We can also do SSL session caching. Again, that all the SSL termination here and now then say proxy passing to a backend server. The addition of being able to encrypt to the backend server is a nice feature in that we now no longer presume that you have total control of that network and that you know it's a trusted network. We're actually passing it encrypted. It's a different and further configuration, but it can be done now. So in this case, the SSL session cache is in order to terminate on the Nginx server and be able to have all of that computational work offloaded from your application server. Simple stuff. Default 5-minute timeout, that kind of thing. So the cache example here, we set up a cache size. Again, it's shared. We're naming it SSL. It's 10 megs big. We have a timeout after 10 minutes, and the server is now listening on 443. Let me go back here before I do that one.
Is that 1 to 4,000 ratio pretty memory static, or does that alter based on volume?
It's a pretty memory static, actually. It's a good benchmark to just be like, we will put it here. Occasionally, you'll find something that's, you know.
We'll throw it out of whack, but.
Right. But for the most part, that's pretty standard for us. Yeah. Other questions? No? All right. Well then, since I got asked this question yesterday, I threw in a slide just quick. We have in Nginx Plus, because we are now a company and we do want to pay our open source developers, because it turns out they have rent and mortgages and things like that, like all the rest of us. So what's different in Nginx Plus, we've gone and added features that most of them can be made to work. Most of these features can exist with either additional software or heavier configuration or additional scripting outside of Nginx in the open source product or with third-party modules. But we wanted to make this a little bit of an easier on-ramp for the people or the companies who say, I'd rather have the security and safety of someone to call, and I really don't feel like trying to write all of the interface to syslog, for example, or you know, that's great that you've got this status module, but I really want to be able to pull that out in JSON. So things like that got added into Nginx Plus. So there are further load balancing features. Further caching features, some of those caching features are some of the more granular knobs and dials and caching. We've seen a lot of people who are interested in higher performing and higher different ways to work with video with Nginx. So we've added a lot of video features for live streaming within Nginx Plus. The monitoring stuff, like I said, the status module can be pulled out as, or the status information can now be pulled as JSON. A lot of the things we've added are also really good automation tools. So like the status, again, the JSON of the status or on-the-fly reconfiguration of your upstream pools, syslogging, and then the functionally the insurance, the support and services as well as application health checking. So you guys asked over in that general direction about upstream checking. You can do deep pings with Nginx Plus, so you could go looking for a specific, not just a specific response, not just a 200, but I want to make sure that I can get the copyright information off the bottom of the page because I pulled that out of the database for some reason. So you can do a deep ping with the application health checks. Online, of course, we have all sorts more information. One of the other benefits of us becoming a real company and being able to hire more people who are not just doing this for love of software and country, is that we are doing more documentation, more evangelism, more outreach, more actual application and use case-based documentation as opposed to just straight up engineering directive and argument kind of stuff. So I recommend very strongly for the half or so of you that said you hadn't played with it, go play with Nginx Plus. It's free, it's easy. For those of you who may have organizations that want that insurance, check out Nginx Plus. There's a 30-day free trial on that as well. And I am Sarah. Thank you for your time.